Hi everyone, welcome to this first video on lesson 13 of the variation and inheritance scheme of work. This first video is, I'm going to go through an exposition that I think is relevant to all students. This is about Lamarck's theory of inheritance, as the lesson suggests. And the second one is goes a bit further than that and kind of gives a mechanism for inheritance. That's maybe not for every single student, but this is super important. And it's worth stressing why we do this, because this is, I remember being taught about this at school, and you may do as well, learning about giraffes and why do giraffes have long necks and things like that. There's always this question floats around a lesson like this where it's like, why are we teaching them the wrong theory? And I think it's worth having that in mind, because actually it raises a really important question about why are we teaching science. Yes, we want them to have the best theory that we currently have about inheritance, which is the theory of natural selection, as articulated so eloquently by Darwin. But we also want to give them a sense, not just, okay, this is natural selection, learn it, but also how is it that this theory came to be accepted. And perhaps the reason it's important in this topic is because this is still a contested area. Perhaps less so in the UK, but certainly in the US, this is an area where there are still people battling at legislative, if I can say that word, level, over whether evolution should even be taught in schools. So it's really important to say, well, this isn't just something Darwin pulled out of his head. There's really good reasons for thinking about inheritance in this way. So this is why we teach it, and it's why it's worth just taking your time to read up on this this episode in the history of science and really think about how to explain it to students. And I think what we often forget when we teach this is what the context was like in the kind of late 1700s, early 1800s, how people thought about species and humanity's place in the universe. And what you've got to remember is nearly 2,000 years of Christianity at that time had made people assumed that humans were a really special kind of a species apart that were completely different to animals, and had been, all of the species had been created by God. So what I'm going to do is contrast in this lesson, when I'm explaining this to students, with I'm going to contrast the religious view, that puts humans as a species apart, with a more modern view, in this case Lamarck's view. So I'm going to put the Lamarckian view over here. And it's worth emphasizing, we learn about this, and certainly when I learned about this at school, I was like, oh, Lamarck must have been this kind of old-fashioned, not very intelligent kind of guy. But what we want to emphasize to students is just how radical Lamarck's thinking was, and he was essentially bullied out of any sort of recognition or fame during his lifetime. He died in poverty because people thought his ideas were just too threatening to the existing order. So it's a really important next step before we get to Darwin to understand what Lamarck was thinking. Now, the context that we need to give to students is that the religious view at the time, and again, I'm simplifying here. There's a great book called Magisteria about the relationship between religion and science, which I would recommend if you're interested in this. It's a lot more complicated than it often gets made out. Another great book is Impossible Monsters, which I read recently, which is also fantastic. That's about the discovery of dinosaurs and how that relates to all this sort of science. But essentially, the religious view that we're going to pass on to students is that in the beginning, animals were created. So here I'm going to do a very rudimentary drawing of a giraffe. This was what giraffes look like at creation. And you can go back to Genesis and so on, which many of them will be familiar with. And essentially, species haven't changed. Species are constant. They were created in the beginning, and that was it. And there were lots of reasons put forward for believing this that go way beyond what's written in Genesis, but essentially, that is what people believed. So what we need to understand is, well, how did Lamarck think this was different? And the reason his ideas were so radical is he started to suggest that there was this possibility that species could change. There was a possibility that species could start out as something and end up as something else. And that went completely against everything that people at the time thought was even possible. Now Lamarck, again, you may remember this from school, and this is how I would go through it with the students. He had this idea that what was passed on was changes that happened during an organism's lifetime. So we're going to use the example of a giraffe again. So let's imagine a giraffe like this. And when it's young, it only has a very small neck. But it really wants to get up to these fruits. Maybe I'll draw some fruits up in the tall trees. And it strains its neck and strains its neck and strains its neck over the course of its lifetime, so that by the time that it's older, after stretching for all of those years, what this giraffe looks like is a bit more like this. So it's still got the same length legs, let's say, but now it's stretched its neck so much that it's got a very long neck. So this is when it's young. This is when it's become older. Now, Lamarck's point was that these adaptations that happen during an organism's lifetime are then passed on to the giraffe's offspring. The point being that because this giraffe's neck stretched throughout the giraffe's lifetime, it then passes that on to its offspring as follows. So I can draw a few of these. That one's not actually the longest, is it? But anyway. Hopefully you and your students will get the idea here, so we can do, you might want to do better diagrams than mine, but hopefully this makes sense, that long neck, because it grew during the giraffe's lifetime, that is then passed on to the offspring. And so that's the really simple idea. And again, there's other examples in the slides. I think there's a swordfish, there's the finches again. I use the example of a woman doing lots of strength training and building up big muscles. Lamarck's theory would say that if a woman builds up really big muscles because she's done lots of strength training, then her baby is going to be born, essentially, maybe not the baby itself, but her offspring is going to end up having big muscles. Whereas what we want to contrast that with is the modern theory. And again, students will have some familiarity of this, but the modern theory would be no. Organisms are born with the new characteristic, and they don't develop it. Yeah, what they develop during the lifetime isn't passed on. They're either born with it or they're not. But what we need then, following that, is a mechanism to explain how that happens. Now, that's what we'll look at in the second part of this video. I would say that's an extension. Sorry, the second part of this lesson. There'll be another video about that as well. I would say that's an extension, because actually we really want to give them the correct mechanism here. We don't want to confuse them with the wrong mechanism. That said, I think it's a fantastic insight into scientific thinking. So if you've got a high prioritaining group, I would definitely be watching part 2 of this video and going through the second half of this lesson on pangenesis and gemmules, because it's a really good example of the guess-deduce-check model of science, and how that has allowed our thinking to develop. But this, I would say, is the essential part of the lesson, and you can move on to the other part depending on your group.